Hello everyone, in this video I am going to explain you insertion operation in double linked list. Okay, first let me explain you the concept and then let me move into the program. See, if you take a double linked list, you have three options to insert. Okay, first is to insert in the beginning, the second is to insert at the end, and the third is to insert at a specific position. Okay, you can insert in any of these three. Okay, if you want to insert an element, you can insert in any of these three. Okay, first on seeing insertion at the beginning, see, consider these nodes. Okay, consider a double linked list. You know this basic structure of double linked list, right? The first node contains the address of the previous node, and the last node contains the address of the next node, and the middle node consists of the data, okay, of this node, of the current node. Okay, I hope you understand this. Okay, I hope you know the basic concepts of double linked list, and then only you are coming into the program. I hope that. Okay, if you are not uh, thorough with the double linked list, first study what is double linked list and then come into this program. Okay, first, if you want to insert any element in the beginning, okay, let me show you the concept. In that case, okay, first consider this as an element which is already existing. This is the first element, and this was existing before as first element. Okay, now you want to enter this new node as the first node, and you must make this node as a second node. That is, new node's next node must be this node, and new node must be the head, and new node must be the first node. Okay, so what are the changes would happen? You see, if you want to make some node a first node, see, first the address of the previous node must be null. Okay, the address of the next node must contain the address of the node which was already the first node. I hope you understand. This node must be null, and this node must contain address of the node which was the first node. Okay, which was the first node. Now this is the first node, which was the first node means this node. Okay, so consider ptr's previous is equal to null, and ptr's next is equal to head. This was the head, right? And this was the head, and this is the ptr's previous. Head is equal to ptr's previous is equal to head. Head's previous is equal to ptr. Head is equal to ptr. Then we are assigning ptr as head. That's all. This is a very simple concept. First, ptr's previous is equal to null, ptr's next is equal to head, head's previous is equal to ptr, head is equal to ptr. That's all. A very simple concept, right? So let me show you the code. First, you are taking some library functions, header files here, and then struct mode of struct node and int data. What is data means? Let me explain you full here. Okay. Then struct node of previous. You are having one previous node, and we are having one next node. Consider. Okay. And head, we must have head. What is head? Head, as I told, head is a some node, and we initially it was null. Okay, initially the node was null. Okay, that is this. Okay, now so insert at the beginning. What is insert at the beginning means? So inserting as the concept, as I told, that is the that is going to be program here. Okay, why insert at beginning means we must create a new node called new node. Okay, we are creating a new node called new node. Okay, we are assigning the memory space for that. For a node which must be present there, you must first allocate the memory of that, right? So we are allocating memory of that. If new node is equal to null, what does that mean? If new node, after doing many operations also, if new node is equal to null, then the memory space is not allocated. Okay, that is the meaning of that. Memory allocation failed. Okay, so this is the if new node is equal to null, this will be printed. Okay, else printf, enter the data you want to insert. You must enter the data you want to insert, that is new nodes data. As we declared here data, that data is new nodes data. So enter the data you want to insert means you must enter new nodes data. So new nodes previous is equal to null, as I told, new nodes previous is equal to null, right? So this is insert the beginning, new nodes previous is equal to null, new nodes next is equal to head. Okay, new nodes next is equal to head. If head not equal to null, that is, in some cases head may be equal to null. If head equal to null means, what is the scenario? Both head equal to null means the new node acts as the new node as well as head as well as tail. Okay, so let me explain you. If head not equal to null, head's previous is equal to new node. That is, if new node not equal to null means head's previous, head's previous is equal to new node. Okay, so let me show you the program. uh, See, if head not equal to null means, if some element exists means, we must make head's previous is equal to new node. First consider new nodes previous is equal to null. New nodes next is equal to head. Okay. New nodes next is equal to head. If head not equal to that head does not exist. Okay. If that head does not exist, you must make heads previous is if that head exists means you must make heads previous is equal to new node. If that node does not exist, you need not make this a statement. Okay. First we are assigning new nodes next is equal to head, then directly we can put head is equal to new node. Okay. If in case of if head equal to null, if head not equal to null, that case if some element is present there, heads previous is equal to new node. Heads previous is equal to new node. As we assigned here, new nodes next is equal to head. Heads previous is equal to new node. Okay. Then head is equal to new node. Okay. Then let me explain the I hope you are clear with insertion at the beginning. So let me now explain you insertion at the end concept. Okay. So this is the concept of insertion at the end. So as I said before, in case of insertion at the beginning, the head, that is this address of the previous node, must be null. In case of the inserting at the end, that is inserting a tail as a tail node, you must make the last node as null. I hope you understand. Okay. Temps we for this scenario, what we are doing, we are placing this as head. So let me explain you. First we need a new node. Okay, okay, we need a new node. So we are containing we are assuming another variable called tail. While why we are assuming tail? Only after tail you can add some value, so that value becomes tail. See, let me explain you. You are adding some element here. Okay, you are adding some element. So this was basically the tail, this was basically the last node, and you are adding some element. So this element only becomes a tail. Okay, and for making that only we are making this program. Okay, new node we are allocating some memory. So the same scenario, enter the new node's data. If new node's next is equal to null, as I told before, new node's next is equal to null. If head equal to null means what will happen? If head equal to null means what will happen? Head does not contain any value. Okay, then what will happen? New node's previous is equal to null, head is equal to new node. See, if head not equal to null, that is no head exists, then no tail will obviously exist, that right? So insertion at the end means that only one new node which is allocated here will act as the only node. Okay, so head is equal to new node. Okay, I hope you understand. If head equal to null, that is if no element exists in the linked list, so head is equal to new node, right? New node is head is equal, that is the new only new node acts as both head and tail, and that is only node present there. Okay, new node's previous is equal to null. As I told, new node's previous will also become null since head is equal to null. What is the condition of head equal to null? The previous should be null. So that this, if this scenario happens, new node's previous is equal to will be null and head is equal to new node. Else tail is equal to head. Why we are assuming tail is equal to head means assuming head is equal to tail, we must move this till it becomes null. If it becomes null means what will happen? That will be the last node. I hope you understand. We are assuming this as tail. Okay, first we are assuming this as tail, and we are moving this tail till it ends here. See, if you are not, we are not adding this node first, so till it reaches the last value. This would be the last value without adding this, right? So this would be the last value. I hope that you understand. This was the tail. Okay, we are assuming head as tail and we are moving till it reaches the null value, and this was the last node, and we wrote the tail there. Here it is temp. Okay, then tails next is equal to ptr. So new node, right? Tails next is equal to ptr's previous is equal to temp, and ptr's next is equal to null. That's all, very easy. While head is equal to tail, while tails next not equal to null, as I told before, while tails next not equal to null, till it reaches the null value, tail is equal to tails next. While tails next not equal to null value, tail is equal to tails next. Okay, tails next is equal to new node. Assuming, okay, tails next is equal to new node is previous is equal to tail. So this is the only scenario. Okay, as you understand, tail is equal, saying my tail is equal to tails, while tails next not equal to null, tail is equal to tails next. We are moving till it reaches the null value. Tail is equal to tails next. So we got tails next value. Okay, so tails next is equal to new node. We are assuming tails next is equal to new node, and new node's previous is equal to tail. I hope you understand. We are first assigning a head value to tail, then while tail next not equal to null. so not equal to null, okay. While tails next not equal to, that is that the value of the tail till it becomes null value, tails next till it becomes null value, that is you must get the last value, okay. Tail is equal to tails next, okay, assume that, okay. While tails next is equal to new node is equal to tail. I hope you understand. We are moving this till this, okay. Tail is considered this as tail. Tails next is equal to new node. New node's previous is equal to this tail, and tail is equal to, so okay, head is equal, tail is equal to head, okay. I hope you understand this. It's a very easy concept only. Tail is equal to head, while tails next not equal to null. Tail is equal to tails next. Tails next is equal to new node. New node's previous is equal to tail. It's a very simple concept, okay. I hope you understand. Okay, I'll explain you again. First, you're assigning the value of head as tail, okay. While tails next not equal to null, that means what? Tails next not equal to null means what? Till it reaches the last node, move that. We are assuming to move that tail position, okay. Tail till it reaches that. If it reaches that, tail is equal to tails next, okay. Consider tail is equal to tails next. The value tail is equal to tails next. Tails next is equal to new node's previous is equal to tail. That's all. Okay, I hope you understand. Then insert at a specific position we can find. Okay, see, this is also easy only. Let me move this. Okay, I hope it fits here. See, consider this. Okay, head. Consider this as head. Okay. Okay, consider this as head, and this some values, and you must add the values in between these in the sense, because this is 1 2 and 3, okay. You must make a link between 2 and 3. So what we must do, you must add a ptr inside between these two. So what you must do means, so ptr's previous, so you must make a while loop, and you must move that as you consider value temp, and you must move till it reaches this value, okay. Till it reaches this value you must move. I hope you understand. Enter the data, you must get it as temp in type position, and till it reaches position, till it reaches, sorry, no, till it reaches this position, till it reaches this position you must move the temp variable, okay. We are while for looping or any loop, while loop or for loop you can do, and you must move this temporary variable till it reaches position -1 value. If it reaches position -1 value, stop there and consider this as temp, okay. So ptr's previous is equal to temp, this temporary value, okay. ptr's previous is equal to temps next is equal to ptr. I hope you understand. ptr's next is equal to temps next. ptr next is equal to temp next. How I am saying, ptr next is obviously this value. Since this value and this value are same, we are assuming this value as this value. I hope you understand. This is basically belongs to this, okay. So if you are making that so complicated, you must consider another pointer variable for this or another variable for this here, and you must make some complicated things for easy understanding. And this is very easy, since I hope you understand, this and this are equal, this value and this value are equal. We are assigning this, we are indirectly accessing this value. We are assigning this value to this value and indirectly accessing this value. I hope you understand. ptr's next is equal to obviously this one. What is this? Consider some value, okay. Obviously this is previous, okay. But since this value and this value are same, ptr's next is equal to temps next. I hope you understand, okay. Then temps next, what is this? Temps next previous. So this value, right, this value is equal to ptr. This value must become ptr, right? So indirectly we are accessing this value, temps next previous. Temps next previous is equal to ptr. So I hope you understand. This is very easy only. First we are getting these nodes, new node and temp. So we are making and int I and position we are getting. So new node we are allocating some memory. If new node equal to null means what will happen, as we know before, and we are getting the data and we are getting the position. If position less than or equal to 0, so it becomes invalid position. If position equal to 1, it becomes the concept of insertion at the beginning, right? You can directly write insert at beginning, that open bracket and semicolon, open bracket, close bracket, semicolon is for this, okay. And need not write this code, okay. For your understanding, I wrote here. Up to this, that code is over. So for I up to from this only the main code starts. Okay, for I equal to 1, I equal to 1 means what? For we are continuing the for loop from 1. Okay, for I equal to 1, I less than position minus 1. Why position minus 1? Since in computer, in anything, we can assume that first position is 0, right? So we are assuming the first position is 0, so we are making a position minus 1, so it tells us the correct value. I hope you understand. I hope you understand why we are putting position minus 1 here. Okay, I plus plus. Okay, and we are incrementing the value, and temp not equal to null. If position for I, we are you know what is the condition of for loop, right? First one is assignment, and then next is condition, and then increment or decrement operator, right? For I equal to 1, first we are assigning, and then we are evaluating, and we are checking the condition. Okay, I less than position minus 1 and temp not equal to null. While temporary variable not equal to null, what will happen if temp equal to null? Temp equal to null means it does not have any. Temp equal to null means what? It becomes the insertion at beginning, right? Temp equal to null means it's an insertion at beginning, right? So we are making this for loop. Okay, for I equal to 1, I less than position minus 1 and temp not equal to null, I plus plus. We are incrementing the value. Temp equal to temps next. Temp will be equal to temps next. I hope you understand. We are moving the for loop and getting the value of temps next. Okay, while if temp equal to null, that is the temporary value. See, we are assigning here temp equal to not equal to null. If temp equal to null means invalid position field of null. See, what is the value? What is the purpose of temp equal to null? See, we are moving this value. I hope you understand. We are having this value, and temp equal to temps next. If temp equal to null, first we are allocating the memory. See, we are allocating the memory. Let me explain you with this. Okay, first we are allocating the memory, and we are moving this from everything. So if there is nothing, there is no need of this position, right? If this is only variable that should be stored there is no need for this temp, right? You need not move, and you need not waste this time, and you need not waste the space, right? So we are freeing up this temp space. Okay, I hope you understand. If temp equal to null, print of invalid position free of new node. Okay, new nodes previous is equal to temp. I hope you understand. New node, what is the value of this? New nodes previous is equal to temp. New nodes, I hope you understand. New nodes previous is equal to temp means what? New nodes let me explain you. What is this new node? New nodes previous is equal to temp. Then new nodes next will be, then this is new nodes next will be temps next, and temps next is equal to new node, right? Temps next is equal to new node. Temps next previous is equal to new node. Okay, I hope you understand. The same concept here. New node is previous is equal to temp. New nodes next is equal to temps next. If temps next not equal to null, temps next means what? Temps next. What is temps next? This is temp, right? Temps next not equal to null. That is, if some element exists only, you can move. Otherwise, this becomes insertion at the end. Okay. So if temps next not equal to null, temp equal to temps next previous is equal to temp is next is equal to new node. I hope you understand. I hope if you understand this concept only, you can move into that program. Okay, first understand this concept. This is new node, right? New nodes next is equal to temps next. New nodes, this is new node. New nodes next is equal to temps next. Temps next. So this and this is same since temps next. Okay. New nodes previous is equal to temp. New nodes next is equal to new nodes temps next. Then temps next is equal to temps next is equal to new node. Temps next previous is equal to PTR new node. Okay. I hope you understand. Temps next previous is equal to PTR. This values previous is PTR. So how to assign this value? Temps next or the previous only this value. So we are making this. Okay, I hope you understand. First, let me show you insertion at a specific position from the first. Okay, so this is basically the code, and this is insertion at the beginning we are doing, and this is the major code we are coming here. For I equal to 1, I less than position minus 1, I plus plus. See, this is also a part of it. We are saying head is equal to temp. Head is equal to temp means we are moving till it reaches the temp equal till it reaches the null value. Temp not equal to null, and position minus 1 we are making that temp to move forward, temp equal to temps next. Okay, for position -1 till it reaches that, temp equal to temp next. Assigning temps next as temps value. Okay, if temp equal to null means what will happen? Invalid position. Else if what will happen? New nodes previous is equal to null, new nodes next is equal to temps next. If temp so if temps next not equal to null means what will happen? Temps next previous is equal to new node, temp is equal to temps new node is equal to temps next is equal to new node. I hope you understand. You can understand only this by seeing this diagram or seeing this concept. Okay, for I equal to 1, I hope you understand. Okay, this is a little easy. First we are assigning this head as temp, and then we are moving for loop, using for loop we are moving till it reaches the temp value. Temp, we are assigning temp is equal to temps next, and until it reaches the null value, position -1 value. Okay, temps next is now temp. Okay, now new nodes previous is equal to temp, new nodes next is equal to temps next. If temp next not equal to null, that is if it is null means what will happen? It is the insertion at end, right? So if temps next not equal to null, temps next previous is equal to new node, temps next is equal to new node, that's all. Okay, then void display means we are moving assigning a temp variable, and we are assigning it as head, and we are till the temp reaches the null value, print of percentage d comma temps data, temp equal to temp next, and you are moving this. Okay, so print of slash, and that's all. So let me run you the output. So this itself takes a lots of time, I hope. Insertion in the what you want, right? First I want insertion at the beginning, and one insertion at the sorry, then I want insertion at this end, so I want 3 to be inserted. So next I want to insert uh, I wanted to insert 4 in position of 1. So I wanted 4 in position, you want to enter in the second position. Okay, so the value is this becomes 4. So okay, so I have displayed everything. So I make to display the elements are displayed. So if I press exit mean it will be exiting, that's all. So that's all. I hope you understand this concept very well. I tried my level best to explain this concept. So thank you for watching this video fully. Thank you.